Hi guys. So today you're going to do focus question E, and we're gonna do page 7 and then page 8 are the practice problems. I noticed that for some of the other videos there's only like 2 or 3 views on it. So if you're not watching the video, then you're not gonna really understand what you're copying in your notes. And I noticed that the quizzes yesterday, the grades were nowhere near as good. So you do need to watch the video, copy the notes. I'm not going to redo this when I get back because I have given you this lesson. So I expect that you're watching it, recording your notes, and then using that to help you. All right, so atomic mass. So if you look on your periodic table, you'll see that each element has an atomic mass. And you'll notice that it's a decimal number on your reference table. And we've learned already about the mass number. So these two numbers are pretty similar to each other, but not exactly. So the mass number, remember, is the protons and the neutrons, which makes sense to us because we know that the protons and the neutrons are where almost all of the mass is. Remember, the electrons are basically negligible. But they aren't entirely negligible. And we learned yesterday that we do have isotopes of an element. So remember yesterday there were different types of carbon with different mass numbers and different types of magnesium with different mass numbers. All the same atomic number because they're the same element but different mass numbers. So those different mass numbers create this atomic mass that's not an exact number but is a decimal. And so where does that decimal come from? All right, so if we think about if these were your test scores and you had 4 90s and 180, your test average you would expect to be close to 90, right? Because you had 4 90s and you wouldn't expect this 180 to bring down your grade a ton. You wouldn't expect me to say, oh, well, they got 90, 80, so their average is just going to be an 85. You would expect that I would say, okay, I'm going to go 90 plus 90 plus 90 plus 90 plus 80. Add those all up, divide by 5, and get your average that way. Because it should be weighted 4 90s, not just 190. And if I did that, then your average would be an 88, which makes more sense. Okay, so this is the idea behind the atomic masses. They're weighted averages, meaning that whatever there's more of is going to count more in your average. Which makes sense. If you had 4 90s and 180, you wouldn't expect me to just go, oh, okay, 90 plus 80 divide by 2, your average is 85. You would expect me to give you the weight of 4 90s in your average. Okay? All right, so chlorine, for example, has 2 isotopes, chlorine 35 and chlorine 37. So remember, this is the mass number, and this is the mass number. So each one of these has the same number of protons. They're both chlorine. They're both number 17 on the table, so they both have 17 protons, but they're going to have different number of neutrons because they have a different mass number. Okay? So if I was to just average them, I have chlorine 35, chlorine 37, I would expect that the average would be halfway between them and be 36. All right, so if you go and look on your reference table, so take out your periodic table, go find chlorine, and go look up what the decimal atomic mass is, you should see something that's like about 35.5, I think it's 4.3, so on, depending on the table, it'll be rounded in a different way. So you should notice that it's not exactly 36. It's not exactly an average of 35 and 37. So they must be weighted differently. So if my average of the two of them is closer to 35, then that must mean that there's more chlorine 35 than chlorine 37. Okay, so just like up here, my average was closer to 90, so my average must have had more 90s than 80. So here it's closer to 35, so it must have more of the 35 than the 37. Okay, so our atomic mass is a weighted average of all the natural isotopes. So we don't take into account anything that's man-made or anything like that. Okay, now just remember, anywhere along here you can always stop the video, write down what you need to, think about what we need to, and then come back. But I can't stop the video, otherwise it'll take too long for me to upload. All right, so weighted average of all of the natural isotopes. So now we're going to see, where did this 35.543 come from? So if you were to Google and look up, you would find out that of all the chlorine that exists in the world, 76% of it is chlorine 35 and 24% of it is chlorine 37. So that's why we end up with a number that's much closer to 35 because there's a lot more of it. So how do they actually calculate this? Well, just like I'm going to take 4 of the 90s, I'm going to say, well, percents are based on 100, so I have 76 of the 35s. And I'm going to multiply 76 times 35. And I have 24 of the 37s. So I'm going to multiply 76 by 35, just like up here I would take 4 times 90 because there's 4 90s. So 76 times 35 gives us 2,660, and 24 times 37 gives us 888. Okay. So just like up here, if I was to go 4 times 90, right, that'd be 360. I'd have 4 of those, and I have 1 of the 80, and then I take those two numbers and I add them together. So I'm going to take these two numbers now and I'm going to add them together. And then, just like here, I divided by 5 because there were 5 scores. Well, I'm going to divide by 100 because there's 100 scores, or 100 isotopes, because I'm basing it on a percent, and percents are based out of 100. So I'm going to add those two numbers, push equals, and then divide by 100. And you should get 35.48, which is pretty close to what we get on the table, which is always rounded, actually. So you should always, whenever you have to do one of these calculations, you kind of know what the answer is because it's going to be on the reference table. Okay? All right, so I'm going to stop this video and I'm going to upload a second video of page 8 where we practice more of those.